Hello and good morning, all you cool cats and kittens. I broke a record this morning. It was 16 minutes from when I woke up and got out of bed to when I started my car. I did all of this and ate. And I even have my camo sweatpants on with my tennis shoes. I'm pretty comfy today. These notes are for giving you basic derivative review, and we're going to move into derivatives for a little while. So we've done limits basics and brought the limits back. Now we'll do the similar thing, different activities with derivatives. There'll probably be a little bit more notes. And then we'll move on into integration review. Once that's done, we'll take a test on review of AB. I'll talk more about that during the week. It won't be this coming week, so don't worry about that. And once that's done, then we'll move on into our first BC unit, just once we have all these other skills sort of refreshed. So this is just the basics of derivatives today and just notes. So for the weekend in Friday, you don't need to practice if you don't want to. Just get the notes down, and then there's the quizzes that you're also supposed to do today. So don't forget to do the quizzes. It goes in as a quiz score, and I have it set that you can take it twice. It's on limits and continuity. So anyway, and there's links and codes and stuff on the Google Slides. Anyway, let's start with some derivative basics. So remember, derivatives are rates of change. They're slope of tangent lines. They're instantaneous rates of change. So make sure you understand when it says find the slope of the tangent line, find the instantaneous rate of change of that you are taking a derivative. I'm not going to review the power rule because that one you should have down. Let's review how we take the derivative with respect to x of a product of functions. Let's call it f times g. And I should really do f of x times g of x, but these notes are just sort of like a basic. So remember what we said, that the way this rolls off the tongue is first d second plus second d first. So the first function derivative of the second plus the second function derivative of the first. And again, if I go too fast, you just pause me. The derivative of a quotient is not the quotient of the derivatives. It's not f prime over g prime. We remembered this by our little mnemonic, so you probably even have it in your head because we said it so many times last year, but it's low d high minus high d low. Draw that line and square below. So we've got the low function, the derivative of the high function, minus high, d low, draw a line and square the function below. Nice and easy. Low d high minus high d low, draw a line and square below. I don't know what just happened. I hope this is still recording. I've been having issues today. Our chain rule is the derivative of function within a function. Okay, so it might be the derivative with respect to x of the sine of f of x, a linear function inside of a trig function. Remember, for our chain rule, we take the derivative of the outside function. In this case, sine becomes cosine. We keep the guts, or the g of x, intact. So that would be f prime of g of x, so cosine of 5x, times g prime of x. The derivative of the guts in this case is 5. Nice, easy peasy chain rule. And remember, we can have multiple things linked at once. So if this had been e to the sine of 5x, you know, we just layer it more. I don't want to talk about that one because e's coming up. So our trig rules, remember that the derivative of sine x is equal to cosine x. And then we had our little way of remembering that too. We said the derivative of sine is cosine. Cosine's negative sine is negative cosine, and negative cosine is sine. And we said it goes Saint Cloud, negative Saint, negative Cloud, and it ends the way it began. And that gives us all of the derivatives this way and the antiderivatives that way. So when I integrate sine, I get negative cosine. When I derive cosine, I get negative sine. So that was pretty slick for us last year. So the derivative with respect to x of the tangent of x is equal to secant squared. Now that we did say to memorize, but I also said that you need to know how to derive it. You should know how to derive it, because if our memory ever fails us, we have a way of getting it without consulting the World Wide Web. So The reason the derivative of tangent is secant squared is because tangent is really sine over cosine. It's a quotient. So it comes from doing the quotient rule on, I'm having like a little bit of technical difficulty here. I might have to do you can't, you don't know what it is. But anyway, you have to do the quotient rule on that guy. So I'm gonna stop this and I'm gonna have 2 videos for this. So there'll be 2, so give me a second. I've got something coming in on another computer. I'm afraid this is going to crash. So I'm going to end this for now, and then there'll be a continuation later.